And that next idea is how to use identities to do or find a solution to a problem. So in part A here, we have an issue right now because we have a cosec and a secant x. We have two different trig functions. We've seen questions like this a little bit. You know the ones on your pretest which had a sine squared and a cos, and you had to use an identity to get rid of one of those? It's going to be the same kind of idea here. In this first one, the question is, can I change everything to be cos? Yes. 2 times secant would be 2 times 1 over cos, and 2 is 2 over 1. So we can change the equation to just have cos. Now we have to think about all of our equation solving in the past, and we have a cos x in the denominator of an equation. Do you remember what you did in the past when you had x's in the denominator? Oh, I haven't. I'm doing this one, right? That's what I screwed up on. Here we go. We'll start it again. Okay. We'll do A. It starts off the same. Sorry, guys. Change the... There we go. That's better, right? This is on page 610. So again, that 2 is 2 over 1. Don't be tempted to bring the 2 down to the denominator as well. We have 2 sine x equals 3 plus 2 over sine x. So same situation, we have a sine x in our denominator. And so it gets a little bit tricky to solve because we have an x or sine x in the denominator. What we can do, how do you get rid of a sine x in the denominator? You need to multiply, right? And if I multiply this whole side by sine x, you know in an equation if you multiply one side by sine, you need to multiply the other side by sine as well. Now the reason I put it in brackets here, because when you multiply this side by sine, you're actually multiplying everything by sine. And you might remember doing that in an equation in the past where you multiply everything in your equation by 3 or by 4 or by some value. My equation then becomes, on this side, 2 sine squared x equals, on this side, 3 sine x plus 2, because the sine x on the bottom would cancel out. And we get a quadratic equation, which we can move everything over to one side. And attempt to factor it. Does this factor? Well, it would have to be 2 sine x and sine x. To get 2, it's either 1 and 2 or 2 and 1. In this case, my outside makes 4, my inside makes 1. That can make 3 if my outside is negative 4 plus 1. And so we get that sine x is equal to 2, or sine x is equal to negative a half. Is this on our pie plate? Yes. When is sine a half? Pi over 6 family. It's negative. So quadrants 3 and quadrant 4. What about this side? Can we do this without our calculator? It's not on our pie plate. But because it's bigger than 1, that one's not possible for sine. If sine or cos is bigger than 1, it's not possible. Tan, anything's possible with tan. Do a quick check. Now is the time to reread our question. We wanted to solve between 0 and 2 pi. Yes, we don't have to do any changes because of that. Now part B is interesting. Part B is interesting because it's sine is equal to cos. There's a way to change sine squared to cos squared. There's a way to change cos squared to sine squared. But you can't change sine to cos. Okay? In this situation, can you see that we could rearrange this question to get tan? If you would divide both sides by cos, on the left side you would get sine over cos. On the right side you would get 1. You have to be careful that that's possible, because sometimes when you divide you get rid of an answer. But in this case, if cos is 0, can sine equal 0 at the same time? No. So we are okay to divide by cos. We're not actually dividing by 0. And now sine x over cos x turns to tan x. Is that on our pie plate? Yes. Quadrants 1 and quadrant 3. Now I'm going to give you a question to work on. We're not going to do it right now. It's question number 10.